One of the primary limitations when you're building powered up trains is having two outputs. So you can either choose between two motors or a motor and lights. And today we're going to be smashing through that barrier with only a few dollars in parts. So if you haven't seen my video on this train yet, it's a design I got from Rebrickable. I will link everything in the description. I've done a few more modifications, so I've actually have a proper button here. And there is a transclear brick here, so you can actually see what the LED is doing. So if it's red, that means we need to connect the controller. And there we go. And we have dual motors, of course. And we have lights. So we are running PyBricks here, and I will link to the tutorial for that as well. So the way that I accomplish this, let's see if I can get this off without, okay, is making a custom adapter. So these are actually Power Functions train motors here. So let's pull all the wires out here. Let's see that. Let's see if I can get it out of there. Okay. All right. So this is the adapter I made. So these wires are shorted together, and that's to tell the powered up hub that we are running train motors, and then it needs to run as a train motor. So if we were running the standard firmware for a powered up hub, you could just press plus and go up to speed 3 instead of having to hold the button down as you would with other types of motors. And then from there, these are the motor control wires here. So that goes off to two Power Functions plugs. And the reason I did that is because you're going to want one running forwards and one running backwards. Now in this specific case, so this plug has the Lego logo on it. The one under it does not, because this is one that I basically cut the old connector on and flipped it over and reversed the motor. So that's why they're actually being powered from the same plug. So that's an option too, to easily reverse your motors. The problem I had is that apparently a couple of the Power Functions train motors I have don't work that well. So I ended up having to use one that was already reversed, but I have ordered some more. So the Power Functions plugs, they're not hard to find on AliExpress. And I can put a link in the description. Just make sure to choose the right color to make sure you get the right component. Otherwise, it's very, very easy on AliExpress to order the wrong thing, because they kind of sandwich everything together into one listing. And a lot of times it'll show a mismatched picture from what you're actually buying, unless you make sure to go through all the little drop-down menus and pick the right thing. Now we have a powered up plug with just a wire on the other end. I actually got this from eBay. I'm sure you can get this on AliExpress as well. I don't really remember what it cost, maybe about $2 per wire, something like that. It wasn't expensive at all. They seem to be very good. There sometimes is a little bit of plastic you'll have to cut or move away. This one actually looks fine. And they are a bit oversized. So like when I was unplugging it here, it was a little bit of a trick to get it pulled out. But I'd rather have a tight fit than a not tight fit. So I'm going to get all this out of the way, and we're actually going to make one of these cables right here in the video so you can follow along. Okay, so first things first, let's look at the powered up hub. So you've got the two ports in the back here, and we're actually going to go from right to left. Pin 1 and pin 2 are the motor control wires. So that's what we're actually going to go to the Power Functions plugs with. Pin 3 is ground. Pin 4 is VCC, which is going to be 9 volts. Pins 5 and 6 are the ID1 and ID2 pins. And those ID pins are how it tells what type of motor is connected. So in order to make this work correctly for a train motor, we're actually going to short pins 3 and 6 and 4 and 5. So you can see that's what we've done here. We've got 4 and 5 joined together here, and then pins 3 and 6 are joined together here. I'm sure there's a more elegant way you could do this. I actually meant to have like a large piece of heat shrink to put over this, But if you've ever used heat shrink before, you know it has to go on before you join everything together. But this was the prototype. I wanted to make sure it was going to work before I started working on a tutorial. I have made that mistake before, trying to make a tutorial with something untested. So let's go ahead and start with our plug, and I'm going to cut it fairly short here because we really don't need much to work with. And then just kind of start pulling all your wires apart. And then we need to make sure we know which way it's all going to go. What I'm going to do, I'm actually going to pull the batteries out of this just so I know I'm not shorting anything out. And I'm going to plug it in. Okay, this one is a bit tight. Just to make sure we know exactly which wires are which. So again, 1 and 2, these are going to be the motor control wires. So let's put those to the side. Let's take 4 and 5 here, and then 3 and 6 here. So we'll just go through and strip them, and then we will put a little solder and heat shrink to join those together. But for now, we'll just twist them. Just like that. So we're pretty much ready for, well, let me go ahead and strip these as well, because I'm going to go ahead and tin those wires. Okay, so I'm going to go ahead and take it out of here before we start soldering. We'll just grab it with a tool here. Actually, for these wires, let's go ahead and twist these so we don't have the strands going everywhere. Quick sanity check. Yep, we got the right ones twisted together. And soldering iron is heated up, ready to go. So these first two, I'm just going to tin those. I always do a real quick thing when I'm soldering. You want to heat the wire and then start applying solder. You want the wire to be hot, or else you won't get a good connection. That's a very common mistake when you first start soldering. I know I did when I was a kid trying to learn how to. I would just glob the solder and kind of drop it onto things sometimes, and that's not how you get a good solder connection. So these, we are going to be putting heat shrink on, but we'll be able to put it over. You know, if we were joining these wires end to end, we would have to put the heat shrink on beforehand. Ask me how I know. Ow. And they will be hot. Okay, so I've got this very small section of heat shrink, so we'll just cut just a little bit, enough to cover up the exposed wires. Just slide it on over. Like that. Then I've just got a cheap Harbor Freight heat gun to go ahead and shrink that heat shrink. Okay, so we're going to set that to the side. And we're just going to use a bit of this B&Tech Go wire. I do have a full video on making these type of wires and all that. You want 24 gauge and preferably silicone insulated wire. That makes it so much easier to work with. And in the video, I have links to wire on AliExpress if you want to save some money and don't mind waiting a while for it to ship. Or you can get B&Tech Go from Amazon or elsewhere. We need a very short section here. Just something like that is fine. And to make this easier, I'm going to make a power function to power function wire. and then we're going to cut it. Now, normally, if you're making a power function to power function wire, you want to flip it like that with the wire going straight, and that makes sure your polarity is always right if you're trying to power an IR receiver, things like that. In this case, we want them to be swapped. So we're both going to be doing studs up like that. So I'm just going to take the wire, and these pins are the kind of outer pins, and these will be the inner pins here. You can see they're spaced much closer together. So as long as you're making it across here, you're fine, and you're shooting for these middle two pins. So I'm just gonna push it down to get started, something like that. And then we'll go on with the bottom of the connector. And just, you can kind of use something to push down, make sure you get it all snapped together really good. We'll take a multimeter and put it on continuity test. And we'll go ahead and test it before we move on, because if you put both ends on, you won't know which end is the problem. So again, the inner two connectors. So let's try this side. It's a bit of a pain to test when it's bare wire like this. Good. Test the other side before, change it on one side but not the other to make sure you don't have a short circuit. Then you can test that side, that's fine. Then you can kind of quickly go through. We don't have any short circuits, we're good. Also, test the bottom, because these are completely separate pins, and it's very much possible to have a problem on one side and not the other. It'll save you a lot of trouble later on. Get continuity on that side. Continuity on that side, that's good enough. And no short circuits. Now all I have here, I've got a 1x2 plate here. I'm going to put this on the connector. This is the known good side, and we'll do the exact same process with the other side. Okay, now we'll start testing again. Good. Okay, I thought we had a short, but we're good. And we'll test both sides, of course. Now this pin looks like it's pushed up a little bit. I'm actually going to try to push it down to make sure it's piercing into the wire. Let's try that again. Good. No short circuits. And we're done with the multimeter. Now we can take this off. And we're just going to cut this right in the middle. And we'll pull these wires apart and strip them. And now let's go ahead and twist these just to make sure they're not getting all frayed on us. Like that. Okay, and we can just kind of put them back to back like that, so we've got studs out on both sides, and then twist the wires together. Now, this is only necessary if you're looking to do dual motor setups, or if you want this exact setup, you want two plugs and you want them to be reverse polarity from each other. If somehow you have multiple motors that need to go in the same direction, really you could just use a single plug and then just stack them together. But I like that this kind of solves for every use case. if it's a single motor, if it's two, maybe power functions L motors or something, you'll have whatever option you need to get the correct polarity, and they can be different from each other. Now that we have those twisted together, let's go ahead and solder these together. And yep, that looks good. Now we need to join these together. So we need to put our heat shrink on. Since these are going to be joined end to end, we need heat shrink on each of these wires. And if you wanted to do a large piece, that needs to go on as well before you get to that. So I've got a couple pieces here. So this is a very large piece that should be able to go around all of it. And then this is a little bigger than the size we were using earlier, since we're joining 3 wires together. So we don't need a whole lot, just something like that. And let's put one on each lead here. Just like that. And I wonder, it's a little long. I'm going to cut this down just a little bit. We're going to try it. Okay, so let's put all these together and get the big piece all over all of it. And it's a bit of a tight fit, but it'll be fine once we get done here. And since we have a plug going in both directions, it doesn't really matter the polarity here. If a motor is reversed, just swap to the other plug and you're good to go. So let's just try to grab it just like that. And we'll go ahead and join them together. Okay. Now it's going to be a little harder to do the other side, but we'll just try it like this. Nope. Did not get that one. Let's try that again. Definitely want a better connection than that. Okay, that is that's good enough. So then we'll take our medium-sized heat shrink and pull these up. Oh, come here. Just like that. And I'm going to try not to heat up the big piece of heat shrink. If I screw it up, I can just cut it off. It's fine. But we need to get these pieces shrunk first. And also be careful, don't touch that metal bit and don't just blow it on your hands because it is very hot. So that looks good. And we'll just pull the large piece over all of it. And you want to make sure you're not pulling any of these other pieces off. So I'm going to try to hold them together. Something like that. And there we go. Now we'll go ahead and test it, make sure everything's good. Okay, so let's put our batteries back in our hub. Again, go ahead and connect this this way. Actually, yeah, let's go to port A. And I've got two motors here. We'll just use these. So let's connect this one. Okay. All right, so this connector is good, and we'll try the other one. We're good to go. That easy. And then again, we'll be able to use, if I can get it out of there, the powered up LEDs if we want. So that's how I've got the LEDs. I routed these when I first built this with this project in mind. I knew I couldn't use it before I had something like this, so I just had an extra plug hanging out in there, and you know, I'd already had it routed through all of this, and I actually had to modify this even more in order to swap from the powered up to power functions motors. And so when I went back, I actually left a gap in there, so it's easy to get to that front hole and thread the wires through if it ever needs to be changed. If you have a bad motor, things like that, you kind of have to plan for things going wrong. So there you have it. I hope you found this useful. I do want to thank broadly the LEGO community for kind of reverse engineering how these were wired up and everything, which I had seen inside of a power functions or a powered up motor from others' videos, and you can actually look at the circuit board and kind of trace out what's happening. So I had already kind of assumed you're just shorting two of the pairs of wires together in order to make it know that it's a train motor. And I like that this is just, you know, one discrete cable here. I'm not modifying the hub, besides the firmware, which can always be changed back. I'm not modifying the motors. I'm just making an adapter. Because I have done, you know, this is the inside of a city hub, just like this. The battery compartment had battery corrosion, so I stripped the board out of it, and this is actually a 9-volt battery case here. So I can actually turn on the power there, and you know, it still works and everything. Just haven't done anything with it yet. I would need a pretty small locomotive to justify running it from a 9-volt battery, but I do have this in my back pocket if I wanted to use it. But what I could have done is just, you know, maybe drilled some holes up here and ran wires into here, shorted the correct pins here, and then had the motor leads coming out. But again, this was only a couple dollars to make this cable, and I didn't have to heavily modify the hub itself. So this would still be fine to resell on Bricklink or eBay tomorrow or 10 years from now, as long as it still works. So that's why I really like this solution. You can buy cables online. In my opinion, they're very much overpriced for what they are. I don't know what they put into it to have these made or anything like that, but it's only a few dollars in components to make these yourself. So I'd much rather be able to make, you know, 5 of these cables rather than just purchasing one online. So again, I hope this is helpful to folks out there. Shout out to the channel members who help keep the lights on here and help keep things going. It is very much appreciated. Thank you for watching, and we'll see you in the next one.